Alright, finally we're ready for powers of secant. Now in previous videos we've had to memorize some situations and how to treat them, and that's no different here. We're going to treat even powers and odd powers differently. One other note is that in the previous video we did powers of tangent and cotangent, and we only did if you had only tangents. We didn't do a tangent plus secants. This video is going to cover that situation. So if there's secants with tangents, this video covers that. Now, alright, so let's jump in. As usual, the warning, always check a problem for u substitution first. So for example, this thing is just the integration rule for tangent. So bam, that's a tangent. This one, we already have a u and a du set up for the power rule. Teachers love to throw in u substitution problems in the middle of chapters about much harder topics. So right here we've got, if your u is cosecant, cosecant cotangent is your du, and bingo, this would just integrate to cosine to the fourth, maybe with a 1/3 out front or something. So keep an eye out for that. Every single problem on any test, in integration, you want to try u sub before anything else, before you start using the fancy methods. Same thing if you're dealing with integration by parts or trig sub or whatever, you always want to try u sub first. Alright, so first, what to do if your secant, or of course your cosecant, has an even power. What you're going to do is save, just like we set aside some stuff last time, we're going to save two of the secants as secants and convert everything else to tangents. And if you guessed that we're doing that for u substitution reasons, you are correct, to match our du's. So we'll make this, oops, not assigned, we're in a different chapter now, secant squared x times secant squared x dx. Now I'm going to leave this one here as my du for some tangents. And I'm going to convert the secant squared into tangents. So secant squared becomes 1 plus tangent squared. And now, as we've done in previous videos, we're going to sort of break this up into two separate integrals. Don't have to, but it leads to less mistakes if you do it this way. Plus integral of tan. He said as he made a mistake. Not yet. I'm just assuming I'm going to, at some point in here, have my fingers crossed that I'll catch it in time. Alright, so now I got two separate integrals, both of which are straightforward integrations. Integral of secant squared is just tangent. And then integral of tan squared secant squared, if I make my u equal to tangent x, then my du is secant squared x dx, which is this right here. So what I've got is u squared times du, which will be 1/3 u cubed, or in this case tan cubed x plus c. Alright, so even power of secant, save 2 as your du, turn the other 2 or 4 or whatever, because of course when you're pulling out secant squared, if you start with an even power and you pull out 2 as your du, then you're going to have an even number left over, either secant squared left over, or if you started with secant to the 6th, you'll have secant to the 4th, but secant to the 4th you can convert into, you can use a Pythagorean identity twice. So, alright, so it turns out the power of secant is all that matters, even if there's other stuff. So in this problem we've got a tangent, but we also have a secant to the 4th. So we're just going to sort of like ignore the tangent, and we're going to say, you know what, that's an even power of secant, so therefore we're going to pull out 2 for the du and convert everything else. Alright, so we're going to have secant squared x, secant squared x, tan x dx. Alright, so one of the secants we're going to set aside and use our du. Then the other one we're going to switch. So this first secant squared I'll convert to tan squared plus 1. And then I'll write down the tangent x, because I want this, I'm just going to do a little switcheroo in order to switch these two, so the secant squared goes with the dx. And finally we have the secant squared x dx. Alright, so as usual at this point, I want to distribute things out, but you know what? I'm going to do this super slow so we don't make any mistakes. First, for this next step, I'm just going to distribute this tan x into this term. So I'll get tan cubed plus tan x. Secant squared x. All right, so at this point I think we haven't made any mistakes. That's good. So now I'm going to turn this into two separate integrals, one for this term and one for this term. So we got tan cubed x, secant squared x dx, plus the integral of tan x, secant squared x dx. Now this is pretty well hidden, but these are actually both power rule integrations. This first one's pretty obvious. You make your u equal tan x, and therefore your du is going to be equal to secant squared x dx, and oh, what a shock, there it is. So this just integrates to 1/4 tan the fourth. The second one doesn't look as much like a power rule because remember the secant squared is part of your du. But that actually is a power rule. I can just say, hey, well I'm gonna say this is u to the first, so u equals tan x, and the integral of u is just 1/2 u squared. So 1/2 tan squared x plus c. Alright, so once again, you'll notice how that tangent, all that did, the previous problem we just had secant to the fourth without the tangent, so we had this and we had this in the previous problem. In this problem we added a tangent to the mix, which went to here, but all that ended up doing was just raising the two powers of tangent right here to 3 and 1 instead of 2 and 0. So instead of tan squared plus 1, we have tan cubed plus tangent, but either way that's still just a power rule. So we just ended up with our final answer having one higher power of tangent for both terms, and of course it tweaked our coefficients a little bit as well. Alright, so the point is that even powers are all that matter, as long as even powers of secant or cosecant. So here's one with cosecants, but we're going to do the exact same thing. So I want to convert the cosecants. First of all, so I have an even power of cosecant, which means that I want to break them up using the Pythagorean identities. So I'm just going to turn that cosecant to the fourth into cosecant squared times cosecant squared. And that cotangent squared is just going to be along for the ride. So I'll convert that first one to cotangent squared squared x plus 1. Then we got, I'm going to rearrange the order here and just switch these guys, so that, because that cosecant squared, the whole reason I'm doing this is to make that part of my du. So I'll put the cotangent squared next. Then I got my cosecant squared. Alright, so now, as usual, to make this a little bit smoother, I'm going to do one step at a time. So first I'm going to integrate distribute the cotangent squareds all together. So I'll have cotangent fourth plus cotangent squared x times cosecant squared x dx. Now I'll make two separate integrals out of it, so cotangent fourth x cosecant squared x dx plus integral of cotangent squared x cosecant squared x dx. Alright, so once again, two power rules. The one subtlety here is if u equals cotangent, du is actually negative cosecant squared x. So that means I need a negative here in order to match my du, which means I'll have to put a negative out front. And of course the same thing's going to happen here. U equals cotangent, therefore du equals negative cosecant squared. So that means I need a negative here, and therefore a negative out front. So I get negative, this is just u to the fourth, so it integrates to 1/5 times cotangent to the fifth x. And then we got a cotangent squared becomes 1/3 cotangent cubed. Alright, so pretty sweet. So if you have an even power of secant or cosecant, save two of them as your du once again. So we'll have this sitting here just waiting for us to help us integrate all the cotangents that we're going to turn everything else into. Secant squared, secant to the fourth. We're going to set aside the secant squared like I showed you earlier in this video. If it's an odd power secant, that's where things get weird. So the first thing we did is integration by parts. On this one we've got a tangent. to work with also. And it turns out that's actually really great. So what's going to happen is that we're going to save a secant tangent as our du. So what we're going to do is we're going to say, you know what? I've got some secants. So I could just do a power rule on secant with u equals secant. The problem is the derivative of secant, so my du would be secant x tan x dx. I've got the tangent right here in the dx. What I'm missing is a secant. But oh, look at this. I've got a bunch of secants I can use. So what I'm going to do is I'm going to take one secant out of here and put it with the tangent to make that part of my du. So I need a secant x, and I'm going to take one of my secants and put that right here to go along with my tan x dx. So now I've got a du perfectly for secants. The only trick is that I had to use one of my three secants as part of to put right here as part of my du, which means I've only got two left. So now I've got secant squared all that, but that's okay. U equals secant x still, I can do the power rule. So really is the integral of u squared du, which is just 1/2 u squared plus c, so that's going to be 1/2. And since my u was secant, that's 1/2 secant squared x plus c. Alright, so odd powers of secant, when you have a tangent also, you can just looking to form, sort of like separate away a secant tangent to use as your du. Alright, so in this last one, we've raised the power of tangent from 1 to 3, but doesn't change our strategy. Anytime you have an odd power of secant along with some tangents, you're going to try and set aside a secant tangent. So I'm immediately just going to set aside a secant x tan x dx, because I know that the whole strategy of these problems with odd powers of secant and a tangent in there is I want to create a du if I can for a power of secant. So once I've set aside a secant and a tangent, what I've got right left is a secant to the fourth and a tangent squared. So at this point, my du is all set up for a power of secant, but I've still got these tangents. So what I want to do is convert these tangents to secants using the usual Pythagorean strategy. So that secant to the fourth stays secant to the fourth. Tan squared is going to be secant squared minus 1. And of course I've still got my secant and my tangent. Alright, so at this point we just want to make a couple of different problems out of this puppy. Alright, so secant to the fourth times secant squared gives me secant to the 6x. And then I got my secant tan x dx minus 1 times secant to the fourth, so secant to the fourth. I got my secant x tan x dx. Alright, so I got two separate problems, each of which has a u of secant, and then my du's are all matched up, right? So there's my du, so I'm all good for power rule on secants. So secant of the 6th integrates to 1/7 times secant to the 7th x. And then that secant of the 4th becomes 1/5 secant to the 5th and plus c. Ugh. So that's what's going on. If anytime you've got powers of secant, a lot of times there's going to be tangents thrown in there. And even if there aren't, you might end up creating some yourself. So if it's an even power of secant, we're going to be doing what I showed you earlier, where you set aside a secant squared and convert everything else to tangents. If it's an odd power of secant, you're going to want to create a secant tangent, or use integration by parts. If there's no tangents, like on that secant cubed problem, you might have to use integration by parts. But there's one of those, this whole trig integral thing is one of those deals where, even though I can sort of tell you the rules the way I think about it, you might want to create your own set of rules, your own set of way to remember the different types of problem. But the point is, you're going to want to sort of memorize 5 or 7 cases, whether it be odd powers of tangent or even powers of sine and cosine, you name it. And you also want to sort of take a cue from what your teacher has put on quizzes and homeworks. So if it turns out your teacher is not that bad and seems to only use certain types of problems and never uses cosecant, only uses secant, and hardly ever uses even powers of sine and cosine. It's almost always odd powers. Just take your cue from the problems on the homeworks and then the quizzes, anything you've seen before in class. Study that stuff, because teachers do tend to stick to one type of problem, or at least they're not going to throw something super hard on the test if they've made it easier on the quizzes or the homeworks. So just communicate with your teacher, try and find out any clues you can get on how hard they'll be, what type of problem they'll be, and then come up with your own list. And I would recommend just making a sheet of paper that has your wording of the different rules, call it your cookbook sheet or whatever, for trig integrals, and just make that list with your wording, how you remember it, how you like it, and just keep reviewing that and memorizing it and practicing, so that once you get on the test, you won't get in one of those frozen type situations where you're like, oh my gosh, how do I match the DU? You don't want to be in that situation. So